Hello friends, welcome once again to the eMath learning platform. This is still your teacher Peter Ikhaja, going to take you through the continuation of, derivatives of inverse trig functions. But before we go for the continuation, I would like to challenge you with this simple assignment because you're going to basically use the knowledge we had in the previous episode of differentiating inverse trig functions. So try out these questions. The good thing is that I've put for you the answers for each of them, so you struggle so much and make sure you arrive at the answer. Now let us look at more technical questions about differentiating inverse trig functions. Okay, so our very first example is going to be this question that we have here. It says given that y is equals to tan inverse of 2x out of 1 minus x squared, show that dy dx is 2 out of 1 plus x squared. Good. So what are we going to do? We are going to begin from this very point where they gave us y as tan inverse of 2x divided by 1 minus x squared. So if that is true, then it implies that tan of y is actually going to be 2x divided by 1 minus x squared. Now the next step, of course, is going to be differentiating the left hand side and the right hand side with respect to x. Now what are we going to do? When you differentiate tan y with respect to x, you expect to get sec squared y about dy dx. Then to differentiate the right hand side, we are going to employ the quotient rule, and where we are going to call this v and this will be u. So I will say v, which is 1 minus x squared, into brackets. I differentiate the numerator, which is going to give us 2, minus the numerator, which is 2x, because that is our u. Differentiate the denominator, that will be minus 2x. Then all this divided by 1 minus x squared, but all squared. So I've applied the quotient rule on the right. And then the next step is going to be basically the simplification. We could first handle the right hand side and make it more easier. So we have sec squared dy dx is equals to, I'm opening the brackets, 2 by 1 is 2, 2 by minus x squared is minus 2x squared, and minus 2x by minus 2x we get positive 4x squared. All this divided by 1 minus x squared but squared. So now we can also now break down the sec squared. We take it back to 1 plus tan squared of y, so that we have all that into dy dx. And this is equals to, we can realize that this and this can be combined, so that we have 2 plus 2x squared. All this divided by 1 minus x squared, but squared. Now when you look back, you realize that tan y is already 2x out of 1 minus x squared. So it means I will do the substitution here, so that I have tan y as 2x out of 1 minus x squared, but remember all of it is squared. Then I have that bracket and all that into dy dx, giving us, I can pull out the 2, so that I have 2 into 1 plus x squared divided by 1 minus x squared, but all squared. So the next step is going to be simplifying the left hand side, and then we see how the automatic simplification can happen. So we shall now have to realize that both the numerator and the denominator are going to be squared, so that now we have 1 plus, that will be 4x squared divided by 1 minus x squared but squared, all this into dy dx, giving us 2 into 1 plus x squared, but out of 1 minus x squared but all squared. Then from this point the LCM automatically will be 1 minus x squared but squared, so that we have 1 minus x squared but squared. And if we divide this by this, we get this very expression multiplied by 1. shall get 1 minus x squared, but squared. Of course, it will be plus the 4x squared. But remember, all this is into dy dx, giving us 2 into 1 minus x, 1 plus x squared out of 1 minus x squared, but all squared. So when we now look back here, we can realize that the denominator we have here is the same as the denominator we have here. So they can cancel out. So that one will remain with 1 minus x squared but squared, which can be expanded to give us 1 minus 2x squared plus x power 4. Then plus our 4x squared. All this into dy dx is equals to 2 into 1 plus x squared. Now when you get back here, this and this can be combined so that we have x power 4 plus 2x squared plus 1. All this into dy dx, giving us 2 into 1 plus x squared. Then we can do the division, but before we do so, you realize that x power 4 plus 2x squared plus 1 is actually as good as 1 plus x squared but squared. Actually, when you try to expand this, you will get this expression. So it means I will now have to write dy dx as 2 into 1 plus x squared divided by this expression, which is as good as x squared plus 1, but all squared. So if you look at this critically, this and this are actually the same. So I can use the idea of indices to simplify this so that I come up with 2 out of, I can now rearrange 1 plus x squared. 2 out of 1 plus x squared. Why? Because this reduces this power by 1. And this becomes the answer they wanted from us. And it was a proof. So that is how we can do it easily.